Alright, we need to talk about rational expressions. And here are a bunch of examples of rational expressions. If you want a definition of what a rational expression is, it's an expression that can be written as p over q, where p is a polynomial and q is a polynomial, but q cannot be 0 because we can't have 0 denominators. What I want to talk about in this video is how to simplify rational expressions. I want to give you some guidelines for what you can and can't do to simplify a rational expression. Let's start by looking at a couple of examples. Here's a rational expression, and because x is a factor in the numerator and x is a factor in the denominator, meaning x is multiplying that 2 in the numerator and the 3 in the denominator, we are allowed to cancel the x's. And we're just left with 2/3 as the simplified rational expression. How about 2x over 4y? Are there any factors in the numerator that are the same as the factors in the denominator? Well, it might not seem like it right away, but 4 can be written as 2 times 2. So 2 is a factor in the numerator as well as the denominator. So we're allowed to cancel the 1, 2 from the numerator with one of the 2's from the denominator. And what we're left with is an x in the numerator and a 2y in the denominator. That is the simplified rational expression. Let's keep going. Okay, this one looks more complicated, but what we have are 2 factors in the numerator and 2 factors in the denominator. Are any factors in the numerator the same as factors in the denominator? Yes. X plus 1 in the numerator is the same as x plus 1 in the denominator. They're both factors, so we're allowed to cancel, and what we're left with is simply x plus 2 in the numerator and x plus 3 in the denominator. Now it would be really tempting to cancel the x here in the numerator with the x here in the denominator. The problem is this x and this x are not factors. They're not multiplying everything else in the numerator or everything else in the denominator. So we're not actually allowed to cancel them. So this right here is as simple as this rational expression gets because we're not allowed to cancel anything further. Now hopefully to cement that concept of when x is a factor, we can look at this fourth problem here and see that x is a factor of the numerator, meaning it multiplies everything else in the numerator, and x is a factor of the denominator as well. Since that's the case, we are allowed to cancel that x with that x, leaving us just with x plus 1 over x minus 1. And while these two factors look similar, x plus 1 and x minus 1, they're not the same, so we can't cancel them. Let's keep going and look at another example. This one is pretty tricky. X plus 1 in the numerator, x squared plus 1 in the denominator. What we might ask is, can we factor x squared plus 1? The answer is no, we can't factor a sum of squares. We could factor this if it was a difference of squares, but there's a plus here. So we can't factor the denominator. The numerator can't be factored. This x and this x squared can't cancel because they're not factors. They're not multiplying everything else in the numerator or denominator. So there's nothing that can be done to simplify this. So in general, in order to cancel a term from the numerator and denominator, those terms must be the same, and they have to both be factors of their respective numerator and denominator. In other words, they have to multiply every single term in the numerator or every single term in the denominator. Let's just look at a couple more examples. How about 2x plus 4 divided by x plus 2? Well, at first glance, it doesn't look like you can do much here. The factor in the numerator is not the same as the factor in the denominator. But if you ask the question, can the numerator or denominator be factored any further? You get a little bit of magic to happen. So the denominator cannot be factored any further, but you'll notice that the numerator has a factor of 2 that can be taken out. If you take that factor of 2 out, you're left with x plus 2. Now, x plus 2 is a factor in the numerator now, and it's a factor in the denominator. So we're allowed to cancel, and we're just left with 2 in the numerator and a 1 technically in the denominator. We don't usually write the 1, so we're just left with 2. Okay, let's do one more example and we'll be finished. Can we reduce this at all? Well, I'm not sure. But what we should probably do to make sure is factor the numerator and denominator separately. Fortunately, we're really good at factoring now, and the numerator factors into x minus 3, x plus 1. The denominator factors into x minus 4, x plus 1. And now you'll notice that there's a factor in the numerator and denominator that are the same. We can cancel them, and we're simply left with an x minus 3 over x minus 4. Okay, we're going to get a lot more practice in class. Don't forget to do the worksheet, bring it to class, and I will see you there.